respect to y is going to be 1 plus x squared plus 2xy. And we want that to be equal to the 0 vector. All right. So okay. Now, so what you could do with this, there's some equations algebraically going to be more of a pain than others, but one way to look at it is this. Suppose we take, for instance, this equation, then if you think of it just in terms of x being a variable, so y is just some number, you can think of this as a quadratic equation in terms of y. So in terms of x, so because we have x here, we have an x squared here, and a constant here. So you can apply the quadratic formula to this to get a value for x that's in terms of y. So you would get x is equal to the coefficient of x, so that's 2y, and you negate it, plus or minus the square root of 4y squared minus 4. Because the quadratic formula, a and c are both going to be equal to 1. Divided by 2, so we get minus y plus or minus square root of y squared minus 1. All right. Now, but the other thing you can do is keep in mind that you can do the same thing with this equation. So y is minus x plus the square root of x squared minus 1. Now, wait, plus or minus rather. Okay. Now, what's interesting is, from this, you can actually come up with a couple of solutions by trial and error. Because if you look at these discriminants here, they're going to be equal to 0 if x or y is equal to plus or minus 1. Then that's just going to go away. So what you can get is a solution that you get x equal to 1 and y equal to minus 1. That's a solution. Also, x is equal to minus 1 and y is equal to 1. Okay. Now, as far as trying to show that those are the only solutions, actually, well, trouble is I looked at the back of the book, so I happen to know that they're the only solutions. Although what I would give you on the exam would be algebraically a little more feasible than this. Something that you could solve in a deterministic fashion. This is what I get for picking problems at random. Because the next thing that I would try, in order to ensure that these are the only solutions, would be, now that I have a formula for y in terms of x, I could take that and plug it in here. So x is equal to minus x plus or minus the square root of x squared minus 1 plus or minus the square root of make sure that I have an identity at least. Alright, so wait, that's going to be squared. Alright, so we have here two critical points, but we need to classify them as max, min, or saddle point. So for that, you look at the matrix of second partial derivatives at each of these points. So if we have, so the classification is this. So if the determinant of H, which is fxx, fyy, actually these are the same because they happen to be equal, minus fxy squared is positive, then what we have is, then we have to look at this. If fxx is positive also, you have a min. If fxx is negative, it's a max. So if it's positive, you know it's a max or min. You just got to look at this element to see which one it is. Or if the determinant of H is negative, that's a saddle point. So we need the second partial derivatives. So we need derivative of this with respect to x. Well, that's just going to be 2y. Derivative with respect to y, that's going to be 2x plus 2y. That'll go here and here. And then a derivative of this with respect to y is just going to be 2x. So the determinant of H is going to be 4xy minus 4x plus y squared. So that's going to be 4xy minus 4x squared minus 8xy minus 4y squared. So if we simplify this, then what we end up actually getting is minus x minus y squared. Because oh, wait a minute. No. Shoot, I thought it would work out more simply than that. Okay, fine. There is simplification. This is not the simplification I wanted. Okay, so we're going to get 4, or minus 4 rather, x squared plus xy plus y squared. Okay. Okay. But now, we need to take this and plug in these sets of values. So if you plug in x is 1 and y is minus 1, or vice versa, well, you're going to get a plus 1 here, a plus 1 here, and a minus 1 in the middle. So the whole thing is going to, because of a minus 4 out front, it's going to turn out to be negative. So both of these are saddle points.